Stan Gibilisco here with an illustration of the inverse square law, also known as the law of inverse squares, for visible light. If you have a point source of visible light and an object at a certain distance away, say d, and the total power from that light source is, well, whatever it may be, and this object has a surface area equal to A, if you go twice as far from the point source of light, you end up with 2d for the length of the edge of the square. So the surface area becomes 4a. The total power again of the point source is P, but each one of these little squares only receives a quarter of the total power. This square, the small one, and this square, the big one, receive the same amount of power, P. I didn't mean P as the power of the point source of light. I meant it as the power striking this square and this large square. But you can divide this square into fourths, and each one of these fourths is the same size as this square right there, so the power density is only 1/4 as great, or 1/2 squared. If you double the distance to a particular surface area like this, with light striking perpendicular to it, you double the distance, you cut the power that it gets by a factor of 2 squared, or 4. The power is equal to 1/4, or the inverse of the square of the distance. And that's how that works. And it's all explained for you very nicely and neatly in my book, Optics Demystified, published by McGraw-Hill. I will include a link in the description of this video to the page for this book, so you can get the paperback edition if you want to buy it at Amazon.com. I recommend the paperback, not the electronic version of this or any of my technical books. You can even look inside and see what the table of contents holds for you. Optical effects, laser fundamentals. Oh, we skipped all the way down to chapter 4. It's a very basic, simple, easy to understand. That's why it's called Demystified. At least I should hope it's easy to understand. Optics Demystified explains this and many other phenomena in optics. Stan Gibilisco signing off until I shine the light at you again. So long.